The goal of part 1 of this video is to make the viewer familiar with cleanroom design and function, as well as cleanroom types. The types of contaminants that can threaten the cleanroom environment are described. Part 2 describes cleanroom procedures, such as how cleanroom garments are worn. Because contamination is a principal cause of product failure for microchips, it is critical that the persons working in cleanrooms learn what kinds of contamination affect productivity and how to assure that an optimum manufacturing environment is maintained. There are 4 types of contamination: particulate, chemical, bacterial, and static. Particles of dust, much smaller than the human eye can see, may cause semiconductor device failure. This can be disastrous for productivity. Metric units are used to describe particle size. The most familiar metric measurement is the meter, which is slightly larger than a yard. There are 1 million microns in a meter. A micron is approximately 1/100th the diameter of a human hair. Imagine a piece of dust 1/1000th the diameter of a human hair, and you will have an idea of the size of particle that can destroy products manufactured in semiconductor cleanrooms. Particles can come from the manufacturing area, the products being manufactured, the product containers, the process tools, and the cleanroom personnel. The 2 ways of measuring particle contamination in the cleanroom are density and size. Density is the measure of how many particles are present in the specified volume. Historically, for cleanroom applications, density is based on measuring the number of particles in 1 cubic foot of air. The most sensitive products are manufactured in cleanroom environments where particle density is very low. As the measure of particle density goes down, the allowable particle size also decreases. Particle size is expressed in microns. For example, in a Class 1 cleanroom, there may be no more than 1 particle larger than 0.5 micron in a cubic foot of air. The cleanliness required, and therefore the cleanroom class number, is determined by the nature of the products being manufactured. Fabricating semiconductor devices involves the addition of very thin layers of materials that are etched into fine patterns that have extremely small dimensions. Even an extremely small particle can cause semiconductor device failure if it falls on a critical area of the circuit pattern. Therefore, semiconductor manufacturing demands extremely low contamination levels and the cleanest manufacturing environment available.